Cellular adaptations with respect to growth and differentiation. Adaptations are reversible changes that occur as a response to changes in environment. And it is not just cells that adapt, we as human beings adapt to the changes in our environment. Like it is not the same that we dress at a beach or at a snowy mountain peak. At two different environment conditions, we dress differently, and that is a reversible situation. That is, if the environment change, we'll change the way we dress. So that is a reversible change. Similarly, cells will adapt to the changes or the stresses that the environment provides them, and these adaptations can be in the form of increasing in their size or their numbers, or it can be changing their look, that is what you call the phenotype, or it can be by increasing or decreasing their metabolic activities activity and so on. So that is how they're changing their functions. So that is how a cell adapts. Now the different types of adaptations are hypertrophy, hypoplasia. We'll come to that. First we'll go to hypertrophy. Hypertrophy is one method of adaptation by a cell in which the cell size increases. Suppose this is a cell and this is the nucleus and this is the environment, and this environment uh, causes problems for this cell, and it has to uh, counter that problems only, and that is possible only by increasing the size of the cell. So this is called hypertrophy. So there is no increase in number of cells, there is no cell division, but the cell as such increases in size due to the stress the environment provides the cell. It can be increased pressure overload, work overload, etc., as seen in cardiac muscle. If there is a pressure overload, the cell will hypertrophy because cardiac muscles cannot divide. So when a pressure is given, increased pressure is or a load is put to a cardiac muscle, what they do is they increase in size. So to increase in size, what does the cell have to do? Within a cell, what we have cytoskeletons and we have organelle. So to increase the cell size, the cytoskeleton also has to increase, as well as the organelle. The cytoskeleton as well as the organelle has to increase in numbers and size. So that is how a cell undergoes hypertrophy, as hypertrophy is the increase in size of the cell. Hypertrophy means increase in size of the cell, and it is the best example for hypertrophy is cardiac muscle, and cardiac muscle cannot undergo division, cell division. So when there is increased overload or pressure overload, cardiac muscle will do the work or try to do the work by increasing their size. Now hypertrophy can be physiological or pathological. Physiologically, where do we see this hypertrophy? It can be seen in uterus during pregnancy. During pregnancy, there is increased estrogen, and the estrogen will stimulate the smooth muscles to increase their proteins. That is, the cells will have proteins, the cytoskeleton as well as all these things are made of proteins. So there will be an increased synthesis of smooth muscle protein. That is, the smooth muscle cells will increase in size. And actually the smooth muscle cells also will increase in numbers, but that is a different thing. As for now, this during pregnancy, due to estrogen stimulation, what happens is the uterine muscles, the smooth muscles, will increase in size, and as such the whole uterus, suppose the uterus, the whole uterus also will increase in size so that it can accommodate the fetus. So this is a smooth muscle, and this is the uterus that is increasing in size due to the combined increase of the smooth muscles or increase in size of the smooth muscles. Then another example is the bodybuilders. Suppose this is the hand, forearm of a normal person, and this person he goes to the gym and works out. That is, working out means basically putting pressure or overload is putting up weights means increasing the pressure on the musculature. So what happens is his skeletal muscles will increase in size and hypertrophy. So the gym is the persons who go to a gym, and what happens is basically the size of the muscle, there is hypertrophy of the cells. Suppose this was a cell, the cell size will increase, so basically increasing the whole musculature, and basically that means they can take up a bigger load compared to the initial state. So these are physiological examples for hypertrophy. Pathologically, we have already told is the cardiac muscle. The pathological example for the hypertrophy is the cardiac muscle. Cardiac muscle. That is the pathological example. When there is pressure overload, the cardiac muscle will increase in size. Pressure overload. Right? So that is about the hypertrophy. Basically, the mechanism of hypertrophy. Mechanism is what? Mechanism of hypertrophy is increased protein synthesis. Can be due to increased pressure or increased estrogen or hormonal stimulation. So that is about hypertrophy. Now coming to hypoplasia. Hypoplasia is another adaptation that cells usually undergo. And hypoplasia or hypoplasia, as said, is the increase in cell numbers. So increase in cell numbers is called hyperplasia. And hyperplasia usually coexist with hypertrophy. As I already mentioned, in uterus, when there is estrogenic stimulation, the smooth muscle numbers also increase, not just the size of the smooth muscles. So the smooth muscles, when they get estrogenic stimulation, they increase in size as well as their numbers. So increasing in number is called hypoplasia, right? And that is due to the stimulation. Usually this is due to hormonal stimulation. Again, hypoplasia can also be physiological or pathological. And physiological examples is already told. The physiology example is the female breast. If you look at the female breast during puberty, the size of the female breast will increase. That is due to the stimulation of hormones. Similarly, during pregnancy and lactation, also the size of the breast increase. That is a physiological example. Also, the liver will divide if there is any injury that occurs to the liver. So if you resect a part of liver, the normal liver will grow up and replace that part. Then bone marrow is the tissue that shows hypoplasia beautifully, because if there is any sudden blood loss, and if you look at the marrow, you'll see that there is increased bone marrow production of the precursors, erythroid as well as myeloid, depending on which is deficient. So bone marrow is an example for physiological hyperplasia. And the breast during puberty and the lactation and pregnancy. Then pathological example is endometrial hyperplasia, which due to inappropriate or increased stimulation of hormones, and that can result in abnormal uterine bleeding. The endometrial hyperplasia can result in abnormal uterine bleeding. And what is the mechanism of hyperplasia? Mechanism of hyperplasia is the growth factors. These hormones will induce growth factors, and these growth factors will cause proliferation of the cells. So that is due to growth factor stimulation. So that is about hyperplasia. Now we go to another area, that is atrophy. What is atrophy? Atrophy refers to the reduction in size of an organ or tissue. That is reduction in size or numbers. So it can either be the size that is reduced or the number that is reduced. So a tissue that has undergone hyperplasia hypertrophy can also undergo atrophy to reduce in size, which has gone into hyperplasia can undergo atrophy and decrease in size. So it's kind of opposite to hyperplasia and hypertrophy. And it can also be physiological as well as pathological. Physiological is usually what is seen during embryological development. During embryological development, some like the notochord of the thyroglossal cyst will atrophy and go off. If it persists, it is a problem. So during physiologically embryological stage, the thyroglossal cyst will disappear, and that is the example for physiological atrophy. Pathological, if you look, pathological conditions is the disuse atrophy. Suppose the same person that we take, the muscular guy we take, he had got all these muscles due to lifting weights, and his muscles are hypertrophied. So this guy is a very strong person and he has hypertrophied muscle. Suppose he fell down and broke his bone. He broke his bone, and his hand is in cast for 2 months. What happens is there is no use of his hand. His hand is kept immobile. So there will be disuse atrophy. So he will lose all this musculature. So basically what happens is he will lose all this musculature due to the atrophy of the muscles. And another problem with immobility is that once the muscle atrophies, the bones also will undergo osteoporosis, because the bones maintain their strength or mineralization due to the muscle that pulls onto it. So when there is less muscle force, the bones also, the mineralization of bones also is reduced, or there is resorption and there is osteoporosis. So atrophy due to disuse atrophy is one way of atrophy, and another atrophy is when the tissues that proliferate due to hormones, and suppose those hormones are taken away, then they like the breast. If you take the breast of a female, she had increased during the lactation, and after menopause, what happens? After menopause, there is decreased estrogen stimulation, and that means the breast will atrophy and decrease in size, and that is why after menopause the size of the breast decreases. So the mechanism in this case is, what is the mechanism? Mechanism in atrophy is there will be decreased protein synthesis. So in hypertrophy it was increased protein synthesis, here it is decreased protein synthesis, as well as a degradation by ubiquitin proteasome pathway. So another second mechanism is degradation by ubiquitin proteasome pathway. Basically the ubiquitin protein will bind to the cells, and once it is bound, the protease, it will be degraded by the proteasomes. Ubiquitin will bind to proteins, and the bounded ubiquitin, whatever is bound to ubiquitin, will be degraded by proteasomes. So that is the ubiquitin proteasome pathway. Then another method is autophagy. So by decreased protein synthesis and increased destruction by the ubiquitin proteasome pathway, as well as by autophagy. So here in these two there is destruction, and here there is decreased production. So that is atrophy. Now the last of the adaptations is metaplasia. What is metaplasia? Metaplasia is the change of a cell type. Suppose this is a columnar cell. The cell change of a mature cell type to a completely different mature cell. This is a squamous cell. Okay, so change of one epithelium or any mesenchymal cells, a change of a differentiated cell type. It is not immature, it is a mature cell. So change or a differentiated cell type is, sorry, it is not the change, it is the replacement. So this cell does not change to this. This cell will be replaced. This cell will be replaced by this cell. So one differentiated cell type, here it is columnar, replaced by another differentiated cell type, here is squamous. So one differentiated cell getting replaced by another differentiated cell is called metaplasia. Remember, it is not the same cell that is transforming, but the cell will be removed, and in place of that cell another cell will come, and that can occur by actually reprogramming of the local tissue stem cells. So here the locally there will be stem cells. Once this is gone, some any disturbance in the environment occurs, the stem cells here will produce this differentiated cells. So that is how there's one method. Or otherwise, suppose near the cell there was squamous cells, and this squamous cells will grow into this area. So into this area the squamous cells can grow in, or one cell type in the nearby vicinity can grow into that area, or the stem cells within that area can reprogram and produce the new cell type instead of the old cell type in that area. So that is what basically metaplasia is. And metaplasia, the example is, if you take the lung, um, it is usually lined by, or it is lined by columnar epithelium, seriated columnar epithelium. But if a person smokes cigarettes, and smoking cigarettes will cause irritation in the bronchial tree and or respiratory tract, and what happens is this columnar epithelium is very fragile, and it cannot withstand this stress. So the squamous epithelium is more robust, and this will be replaced by the squamous epithelia. So a columnar cell replaced by a squamous cell in respiratory tract in smokers. Now there are instances where the squamous epithelium is replaced by columnar. That is seen in esophagus, lower end of esophagus, in a condition called Barrett esophagus. In Barrett esophagus, suppose this is the esophagus, the lower end of the esophagus is the stomach. Here there will be acid reflux happening. So the squamous epithelium is not very equipped to withstand this acidic pH. So what happens is it gets replaced by an intestinal type of epithelia. So that is what is Barrett esophagus. Now one problem with this is that this has a propensity, that is the squamous cells in esophagus getting replaced to a columnar epithelium. It has a propensity to undergo carcinomatous change and form adenocarcinomas. And in case of lung, the squamous epithelium, metaplasized squamous epithelium, has a chance of causing or transforming to squamous cell carcinoma. And so the metaplasia in this epithelia has a propensity to cause cancer. Now so what we understand is all these were due to or adaptive changes to the environment, and it is basically adaptive. But there is another metaplasia that is called myositis ossificans that occurs in skeletal muscles. Suppose this is your leg, and there is intramuscular hemorrhage due to some trauma. There is intramuscular hemorrhage, and due to this insult there can be bone formation within the skeletal muscle. Within the skeletal muscle there can be bone formation due to intramuscular hemorrhage, that is due to injury. Basically it is not adaptation but metaplasia occurring as a result of injury. An example is myositis ossificans. So that is basically all about adaptations, and the last point is not an adaptation but a metaplasia that is occurring and not as an adaptive change. Thank you.